Hi there. Let me take a few minutes and take you through example 2 on the probability review. So here we're assuming that 70% of Westfield residents are Colts fans, 55% are Harry Potter fans, and the events being a Colts fan and being a Harry Potter fan are independent of one another. So I'm going to write it this way. The probability of being a Colts fan, I'll just write that as the probability of C. We'll call that 0.7. And we'll say the probability of H being a Harry Potter fan, we'll call that 0.55. There's a way we can simplify the notation here. So don't work too hard on part A. What's the probability that a randomly selected resident is not a Harry Potter fan? This is known as the complement of the event. This is the probability of H complement. That means not being a Harry Potter fan, so that would be 1 minus the probability of being a Harry Potter fan. That's simply 0.45. That's what we call a complement. So in part B, what is the probability that a randomly selected resident is a Colts fan and a Harry Potter fan? So because of the independence condition, something special can be done here. The probability of being both a Colts fan and a Harry Potter fan, that is the probability of being a Colts fan times the probability of being a Harry Potter fan. This is a special case. Under independence, the probability of Colts and Harry Potter is the probability of Colts fan times the probability of a Harry Potter fan. So literally we can just multiply these probabilities together. So this is the 0.7 times the 0.55. It's that simple. Don't know what that is, should calculate it. 0.7 times 0.55, we'll need it in the next question. It's 0.385. And now hopefully you'll see why we did this, because in part C, I'm asking you to use your answer to help you find the probability that a randomly selected resident is a Colts fan or a Harry Potter fan. This is a little bit different. This is the probability of a Colts fan or a Harry Potter fan. So notice there is a formula on the formula sheet that can help us with this. So under the probability formulas, notice the probability of an OR event, a union event. I can add the two probabilities together, but then notice what I have to do. I have to subtract away the probability that both of those events happen at the same time. This is the intersection, or sometimes I call it the overlap. We have to subtract off that overlap, and conveniently, we already calculated that in part B. So it would be perfectly fine to take the probability of being a Colts fan, add the probability of being a Harry Potter fan, but then we have to subtract from that the probability of being both a Colts fan and a Harry Potter fan. So fortunately, we've already done some of that work. The probability of being the Colts fan is 0.7. The probability of being the Harry Potter fan is 0.55. And then all we have to subtract off is the overlap from the previous question, the 0.385. And hopefully you'll recognize there has to be some overlap, because these two events, the probability of being a Colts fan and a Harry Potter fan, if you add those together, you get a probability that's more than one. Clearly there's some overlap in there, and we're taking care of that overlap by subtracting the intersection. So if I dump that into my calculator, 0.7 plus 0.55 minus 0.385, that gives me 0.865. So the point of this, I wanted you to remember what a complement looks like. That's 1 minus the original probability. I wanted you to know and remember that when we have independent events, the and or the intersection event we can find by multiplying, and that's helpful because when we want to find a union event or an OR probability, the formula sheet gives us the relationship where we can add together the two original events, but then we have to subtract off the overlap. Hope this has been helpful.